So good morning, everybody. As I hear the church bells ring over here, it's time to start. It's 9 UTC. So I hope everybody can hear me. So if you could just give me a yes sign if you do so. Okay. My name is Liliane Hofer and I'm a forecaster at the Austrian Weather Service. I'm not sitting at the headquarters in Vienna, but over here at a regional center here in Salzburg. So just to get an overview, could you use the star or whatever you would like to use and show me where you're from? So just put a star to the country where you're from, and I hope everybody can find him or herself on this map. Okay, any more stars, or do the other ones want to stay incognito, so to say? So I will just start speaking. So welcome to our August weather briefing. And as this weather briefing takes place in the middle of high summer, I really want to focus on some summer topics and some topics which are kind of important these days in the last weeks. So, okay, as no more stars appear, I will just start with my first slide. I said I will focus on summer topics, but if you look at that natural color RGB from the 1st of August, you see it doesn't look that kind of summer-like, because you see a really large cloud-free area over Western and Central Europe. Not even a heap cloud is appearing, although it's 12 UTC, so afternoon in all those countries. And a nice frontal system over the Atlantic, but as I said, nearly no clouds over here. And the reason for this is this extended high pressure system that really looks for nice conditions as you would expect in autumn or in spring, where no heap clouds appear, also not in the afternoon. So the ridge that is situated over here is suppressing every upward motion. And so as you see now, the overall weather pattern as it was in the beginning of August, I would like to ask you, what do you think, on which feature will I concentrate on? Any idea? While you're thinking about what you would like to hear anything about, we can also take a closer look at the natural colors. So, you know, on the green beam is the visible 0.8 channel, which is quite reflective to vegetation, and therefore you see all this vegetation here in the green colors. Or, yeah, here where the vegetation seems not to be as rich anymore, you see more brown colors. Also over here in the eastern parts of Germany, over France, the hot and dry conditions seem to be visible in the vegetation there. So you don't seem to have an idea on what I would like to concentrate on the next few slides. So I will give you a slight hint. Okay, so we have just one star over the low, over the Atlantic, west of Ireland. So no, that's not, that looks quite interesting, but it's not the feature that I would like to concentrate on. So let's just show me the next slide as a hint. And now that's the dust RGB, as you probably know, as you probably see. And I know you can see the feature really just in light colors, but do you now see what I would like to focus on? You know, it's the dust RGB, so you probably know what to look for, but where can you see it? No ideas so far. So yeah, the first star in the right area. Exactly. So you see here, I mean, it's really in light pinkish colors. You see here a zone of dust coming up from the southwest, and that's mainly what I want to concentrate on the next few slides, as it came to my eye and I just thought, okay, that is not quite a typical area for dust to come up, because yeah, it comes up from the Atlantic. So I wanted to concentrate on where is the dust coming from. But before I start showing you a satellite image from more southern directions, I just want to make a quick repetition what the dust RGB is about. So just that you know what you will see in the next slides. So the dust RGB mainly consists of infrared channels and their differences. And it's a really useful RGB because you have to think that dust is consisting of really small particles, and it's not that easy to get a difference between dust particles and cloud particles. And so this is a really intelligent RGB that helps to differ those two kinds. And I will just show you here the example how one can see whether it's dust or whether it's cirrus. So as you see, dust is rather pinkish, and therefore the red channel is the most important one. So you see here in this image the infrared 12.0 and infrared 10.8 channel, and you see if it comes to dust, this brightness temperature difference, which is on the red beam, is positive because more of the 10.0 beam comes through the dust cloud, and with the cirrus cloud it's quite the opposite. So if we have dust, the red beam is contributing more than if you have a cirrus cloud. So that's the reason why dust shows in pinkish colors. But one thing you have to keep in mind, that even if you see dust, you don't know whether it's in the lower atmospheric layers or in the upper atmospheric layers. You cannot say anything about the concentration. In some areas, dust may also be covered up by some higher clouds, but nevertheless, this RGB is really useful, as we will see in the next few slides. So here we have the same date. We're still at the 1st of August, and you see here the Atlantic ePort. And again, here in really faint pink colors, you see this, which seems to be Sahara dust, coming westwards to the Atlantic and then splitting up into two branches. The one branch we just saw here over there, which brought the dust to the southwestern European countries, and the other branch just transporting the dust westward into the Atlantic. And kind of an interesting situation, what raised all the dust. And for that reason, I just took a look at the EUMeTrain webpage, because they have really some nice pictures over there from that event. And there you see this big thunderstorm cells, and their outflow seems to trigger all those, or seems to lift all those dust into the air. And also here probably there's the outflow which just lifts the dust, and it has to be quite a large amount of dust that was lifted, as we will see in the next slides. Yeah, there you see it's the event started at the end of July, and you see the dust is transported westwards with the current. I will now try to show you a nice animation of this. So I hope everybody has seen this animation. It's quite impressive, and it's not that rare that something like that happens. The last outbreak of such a large amount of dust happened in 2007, if I'm right. Okay, I will just continue with the next slide. And again, I'm really sorry that you didn't see it. So here's a natural color RGB of this dust event, and it's really impressive, because normally you don't really see dust that good at the natural color RGB, and here you just see the big dust cloud all over the Atlantic Ocean, and yeah, looks really impressive to me. So as this large amount of dust is not only affecting aviation in terms of visibility, but probably also the weather, the NOAA sent out some research airplanes, and they tried to investigate the dust clouds. And so from the NOAA hurricane research page, I've got some numbers about the dust. So it traveled about 5,000 kilometers or even more across all the Atlantic with a speed of 50 to 80 kilometers per hour. And the thickness is about 1.5 to 5 kilometers, so it's really thick. And the coverage is about 7 million square kilometers. And if you think that, for example, the USA, the area of the USA is 10 million square kilometers big, you can think, you can just, you see that is a really, really big area with dust over there. And they didn't only measure the dust cloud, they also made some nice pictures like this one. You see the NOAA G4 is a kind of research plane, and this picture was made northeast of Barbados, and you really nicely see the decreased visibility because of the dust and some cumulus coming out of the dust, and yeah, looks really nice to me. So you see, there's quite a lot of dust in the air over the Atlantic Ocean, and so now the question is, does it have any effect on the weather? And one of the most beautiful effects, in my opinion, is that there are beautiful colors visible at the sunset and sunrise in the Caribbean Isles and everywhere where the dust is in the air, and such a large amount of dust, it will really bring beautiful colors to sunsets or sunrise. But the most important effect could be that one on the hurricane activity. So there were some rumors that the dust will prevent the hurricane activity, but those don't seem to be true, because the large-scale conditions like the high sea surface temperatures or the lack of a El Nino southern oscillation are still there. So these large-scale conditions are still favorable for elevated hurricane activity in that region. And so, yeah, we will see what is true, but it seems to be the large-scale conditions really speak for a high hurricane activity in that area. So, as I promised you that this summer weather briefing will really focus on summer topics, I will start now with the next topic that really, I think, affected most of the people in Europe the last weeks, the last days, and for that reason I would like you to concentrate on this red area over here over Central and Southeastern Europe. And this is the ERMAS RGB of last Saturday, 12 UTC, and you see really reddish colors all over that area. And normally red colors in the ERMAS RGB are a sign for a PV advection and therefore for possible rapid cyclogenesis. But, you know, it's a quite large area. This could happen. So I will just overlay the model PV advection. And you see, yeah, in this area, in this really red area here, the values are not that distinct. And the reason for that is that the red colors are in this image not a sign for PV advection, but more for really hot and dry conditions. So let me just show you with the several beams of the ERMAS RGB. So on the red beam, we have the difference of the water vapor channels, and this is a measurement for the moisture in higher levels. And so the drier the air is in the upper troposphere, the larger the contribution of this channel is. On the green beam, we have the infrared difference between the so-called ozone channel and the 10.8 channel. So the hotter the ground, which kind of comes into with this infrared 10.8, the lower the contribution of this green channel. So you probably have seen in some weather briefing where I showed you in winter some really green areas, which are assigned for low temperatures. This is exactly the other effect. So it's really warm, so there is little contribution from the green channel. And as it is really dry, atmosphere, the blue channel brings little contribution. So the result of all this is really red colors, which are assigned for high temperatures. And if you just take a closer look, it's the same date, the same time, and you see here this synop observations, and you see all over this area temperatures around or more than 30 degrees Celsius here. So it was really hot in this area over the weekend, and it was also really hot over here in Austria, and it was kind of a historic event taking place on that Saturday. So we just got a new temperature record over here in Austria because 39.9 degrees Celsius were measured over here in the southern parts of Austria, and this is a new heat record which we got on this weekend. And yeah, the media was kind of disappointed because we didn't get the magical number of 40 degrees, but still I think 39.9 is really hot, especially for an area like Austria. So yeah. And just to stay with all these summer topics, I mean, what if it's really hot in summer, what is never missing, and that are thunderstorms. And I don't know, Vesa and Christina made, and Christina reported about her time at the ESSL testbed in Vienna. And as I was also there, but just a week after Christina, and I really learned a lot of obedience-based forecasting system for thunderstorms. So they just say you need more or less 3 ingredients for severe or heavy thunderstorms, which are moisture, so low-level moisture indices, as we will see in the next, or graphic lifting, so due to some mountain ranges. And if you have those 3 ingredients, some heavy or severe thunderstorms could form. Played with the model field of the equivalent thickness, and you see really over here in this kind of narrow thickness ridge, there are already some heap clouds going on. And so look at you at the 3 ingredients that are needed for severe storms. And I would like to start at this map with the first ingredient, which should be lift best. Lifting conditions will take place on that afternoon. Yellow and red colors really show quite unstable conditions. And also here, I think in Eastern Germany, this looks also kind of orange or red to me. So I think I've now taken a look quite usually at this index, and I think it's really, really helpful to forecast the instability or unstable conditions. So just keep in mind, we have somewhere here our cold front. And now the next slide. It looks kind of empty at first. It's again just visible. As you probably have seen already, is the Astrophex homepage. I think every day a forecast they made, a really detailed forecast, and we will now take a look at it in the next slide. You can also see the Astrophex forecasts in the ePort. You can just overlay them as I did it here, and you see, yeah, okay, the case was really clear on that day, but also the Astrophex guys really said, okay, beware. And yeah, I think it's really a nice case for demonstrating the use of this forecasting method, and also the work Astrophex is doing. And also here, something for David, probably here, some slight lightning risk over the British Isles. Don't know if anything happened there, David, but we will just take a look at the next slide, where we can see what happened. So I picked again the dust RGB, as the severe storms RGB isn't working during the nighttime hours. I just picked dust RGB because you can see the cells here also nicely. So if you remember, we had those red GII values somewhere over here, and we see here a really nice convective complex over northeastern part of Spain, and here also over southern Germany, western Austria. And if you remember, the GII had its highest values over here, and if you just take a look 6 hours later, what happened more during the night, we still see our nice mesoscale convective system over here and also over the Baltic Sea. So yeah, some really severe convection. And so convection is the right word to jump to the situation today. Here you see the air mass RGB from 6 UTC today. Central and Northern Europe. This is a really elongated and complex frontal system with lots of dynamic. And let's just take a look at the overall weather pattern with the help of the 500 hectopascal geopotential height. So you see here kind of a shortwave trough. Over Western Europe, you see this distinct trough moving eastwards just into Central Europe, and this trough in combination with the cold front or the frontal system, sometimes it is occluded, sometimes it's warm active, could be really an explosive mixture for severe weather. Whereas here over the southeastern, still this nice trough, and they really suffer from very, very hot temperatures over there. And again, the STFX forecast this time for today. So this is valid from today 6 UTC until tomorrow 6 UTC. And you see also some level 2 warnings were issued, which means that in this area 50% severe weather is possible. And I just went through their report on the homepage, and they say the largest risk is here at Sardinia and Corsica, mainly because of large hail, severe wind gusts, and heavy precipitation. Because one parameter I didn't present you during the ingredients-based forecast is always also the wind shear. So if you have no shear values or no distinct shear values, you won't have long-living cells. So the more shear, the more long-living the cells are, the more they can develop into MCS or MCC systems. And so here the shear values are really high over that area. So there may be some large hail and even some tornadoes were forecasted by the STFX guys. And the same is true for the Baltic areas. There are also medium to high wind shear values. So today, again, a really bad weather situation, and which will probably end the heat, at least in most parts of Central Europe. Then a lightning warning over the British Isles, probably because of this cold front feature here and the short trough behind it. And so I'm sorry I couldn't present you satellite images from Tuesday because we had a server problem, but on Tuesday a similar situation occurred in Central Europe, and some really severe thunderstorms were reported, especially in Germany. And this hailstone was reported at Tuesday in Germany, and they had really big problems with railways and motorways that had to be closed, and really much damage was done by those thunderstorms. So hopefully today the thunderstorms won't be that bad, just bring cooler air, cooler weather to Central Europe, but hopefully won't bother us anymore. Okay, so thank you, very good. I hope we will see or hear each other at the next weather briefing, and wish you a nice day.